What's that? Okay, so last night's homework stated this: if 10 grams of hydrochloric acid is reacted with more than enough potassium hydroxide. At this point in time, it's been like 2 units ago when we were learning to write formulas from names. So you should know that hydrochloric acid is capital H, capital C, little l. More than enough potassium hydroxide, and potassium is K, hydroxide is OH. Potassium has a 1 plus charge, hydroxide has a 1 negative charge. This has a 1 plus charge and a 1 negative charge, so those are already balanced for you, basically. And it says, what mass of potassium chloride will be produced? So we already know, it's already asking you, already telling you pretty much what one of your two products are. Potassium chloride, that's the one you're going to be looking for over here. And so there's got to be something else produced over here. This is an acid, this is a base, so the other thing we're producing besides this salt is always going to be water, but you could figure out from the fact that it's a double replacement reaction, so the front part of this formula joins up with the back part of this one to make HOH, which you could write as H2O. I just kind of like HOH when I'm doing double replacement reactions. One of the things we need to know is what the physical states are going to be. Hydrochloric acid is aqueous. Potassium hydroxide is aqueous. Now, if you don't know that, you've got to go to your solubility rules to figure it out. The solubility rules say that all group 1 salts are soluble. Means if there's water around, it will be dissolved. Okay, so this is going to be aqueous. It also says down here under hydroxides that all hydroxides are insoluble unless they're bonded with group 1. So this is bonded with group 1. Potassium is in group 1. Group 1 just means it's one of the alkali metals here, or hydrogen. Okay, so it's going to be aqueous. We know whether this is going to be aqueous or not. It says on the solubility rules that chlorides are soluble. No exceptions for potassium. It also says under the first rule here under soluble salts that group 1 salts, and that's a group 1 salt, are going to be soluble. So that's aqueous. And you should already know from having done this enough, in an acid-base reaction, water will be a liquid. Water is a liquid on an acid-base reaction in almost all reactions except for combustion. In combustion, water will be listed as a gas. Okay? So there's our equation. We need to balance the equation. Now, yes, this is already balanced. But I'm from where? Missouri. Okay? And you got to show me that it's balanced, and you do that with an atom inventory. So you got 1 hydrogen here and 1 here, that's 2. 1 chlorine, 1 potassium, 1 oxygen. And over here we have 2 hydrogens, 1 chlorine, 1 potassium, and 1 oxygen. And so you can see now clearly that it's balanced, okay? Now then, we're going to start, it says, with 10 grams of hydrochloric acid. It was 2 zeros, right? Let's see. Yeah. Okay. Grams of HCl. And the question is, how much potassium chloride will be produced? Okay. So we're starting with 10 grams of hydrochloric acid. We need to first convert that to moles, because in stoichiometry, when you always go through moleville. Okay? Always go through moleville. So we've got to convert this into moles. To convert it into moles, we've got to have a molar mass. So we have hydrogen and chlorine. Hydrogen's molar atomic mass is 1.00794. Chlorine is 35.453, I believe. Yep. We have 1 of each. Alright, using rounding rules you learned in Unit 1. You know that these are empty slots, so these two digits get rounded off. You still need to show me what the units and species are. This is going to be grams of HCl. We're going to round it off and write an equality statement when we get our rounded answer. 36.461 grams of HCl, and that's the molar mass. But molar mass by definition is the mass of 1 mole of a substance. All right? So we're going to say that in an equality statement. The mass of 1 mole of this substance. Got it? That's required. In this class, it's required that you write that equality statement. Now, the equality statement then helps us to build this conversion unit. We're going to look at the two sides of the equality statement and pick the side that matches the starting units and species and put that side on the bottom of our conversion unit. Starting amount here has grams of HCl. That's our units and species. This side has grams of HCl, so it matches. So this side of this equality statement goes on the bottom. The other side of the equality statement then is going to be put on the top. We're going to cancel what we can cancel, and we can cancel grams and HCl in the same way that you cancel X's and Y's in algebra. And we're at mole. So we're in Moleville now. But the question is going to take us from HCl to potassium chloride here. If we're going from one species to another, we have to have a molar ratio to get from one species to another. The molar ratio comes from the coefficients in this balanced equation. In this case, we're not showing any coefficients, but those coefficients are implied. Just like in algebra, if you have 1x, you don't usually write 1x, you just write x. In the same way, we don't write 1 HCl, we know that it's 1 HCl. But down here, we're going to say that's 1 mole. The coefficients in the balanced equation can represent individual formula units or can represent moles of those formula units. And we're going to use it to represent moles here. So we're going to say 1 mole from here in the equation, 1 mole of HCl, because it matches this unit and this species, okay? That way we can cancel those. And what goes on the top then is what we're trying to get to, in this case, potassium chloride. And there's 1 mole of that. Okay? Now that we have this in moles, we need to get that into grams in order to know what mass we need. Okay, the question says, what mass of potassium chloride would be produced? Well, then that means we're going to have a molar mass. If you go from grams to moles, you've got to have molar mass. To go from moles to grams, you got to have molar mass. So here's K and Cl. Potassium's atomic mass 39.0983. Chloride we said, or chlorine we said, was 35.453. We have 1 of each in the formula. Now look, sometimes students get confused and they start looking at coefficients, and let's say I had a 2 here. They put a 2 down here. But that's not what we're doing. We're only multiplying by the number of atoms in the formula. It has nothing to do with coefficients. Is everybody clear with that? If there were a 2 here, we wouldn't write a 2 here. We only use the atoms in the balanced formula. The number of atoms in the balanced formula. That's what this multiplier is all about. Okay, so 39, whoops, that's supposed to be an equal sign, 39.0983 and 35.453. Add those together. $74.5513. Again, we've got an empty slot over here, so we underline that digit, and that's grams of KCl. We're going to round that off then. And we're going to get 74.551 grams of potassium chloride. That's the molar mass, but in this class we're always going to say that equals 1 mole of KCl. Let's see here. So we want to write a conversion unit now, matching the units and species here with the side of that equality statement we put down here. Well, this is the side of the equality statement, moles of potassium chloride, that matches what's on the top here. Okay, so we're going to put 1 mole KCl on the bottom. The other side of the equality statement goes on the top. 74.551 grams of KCl. We can cancel moles and KCl, just like X's and Y's in algebra. We're ready to do the math. In your calculator, you put in 10. You can ignore the ones, because multiplying or dividing by ones, that just gives you the same answer, right? So we can ignore ones. We're going to multiply this number times this number, hit equals, then hit divide, put in this number, hit equals again or enter, and you'll get the answer, the unrounded answer you're looking for here. Okay, we'll have to still round off, but that's the unrounded answer we're going to look for. Okay, so 10 times 74.551, enter, divided by 36.461, enter, and there's our unrounded answer we're going to put down here. Units we have left are grams. Species we have left is KCl. Now the rules for rounding off when you have multiplication and division are different than the rules you have for addition and subtraction. So this is addition down here. Multiplication and division, we're going to look at the problem, ignore the counting numbers like these ones, and look for all the measured and calculated numbers. Well, this is measured, this is calculated, this is calculated. We calculated them down here, so we know those two are calculated. And of those measured and calculated numbers, we pick the one with the least digits. That's the first one. It has 4 significant digits. So we want our answer to have 4 significant digits. So we're going to underline all the digits after the first 4. 1, 2, 3, 4. Those are going to be rounded off. And we get 20.45 grams of potassium chloride. And just to make sure that I don't inadvertently give you a count off for a wrong answer because I couldn't find your answer and all the mess some of you have, well, you write, I write that way too. I get tired and I'll write just as ugly as some of you do, okay? But try to be neat. It really helps for you to follow things when you're neat, as well as me, okay? I've seen students mess up their calculations because they couldn't figure out what they just wrote. I mean, it happens. So just be careful, all right? Some of you are real good at that, no problem. But some of us, especially guys, we tend to have a hard time writing neat, don't we?
Yep.
Yep. What? Yes, we are.
Good.
Okay?
Yeah.
All right, so let's count everything that we want to give points for. We want to give a point for each of the formulas in each of the physical states. That's 1, 2, 3, 4, 5, 6, 7, 8. So 8 points for just the equation, okay? We want to give a point for the atom inventory. All right, each of the elements, each of the counts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 points. Okay. In the dimensional analysis problem, we set this up in what's called dimensional analysis because we cancel dimensions of measurement. Okay? We're going to count every number, unit, and species every time we cancel one of those, and all the operators, the time signs and equal signs, underlining, arrow, final answer, as well as this number and the digits here and the units. I mean the units and the species here. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, And so that's 46 for just this part right here. Okay? We want to have points for your molar mass calculations. Starting, you write down your elements, the starting amount you have there, and well, since we're multiplying by 1, I'm only going to count this and this. I would count these times 1s, but since it's just times 1, I'm only going to count what you put here and here. Is that understood?
Yep.
If you ever have times something and you don't put it, that point's gone. But today will be a little bit easier on it, okay? So 1, 2, 3, 4, 5, 6 for the 2. Well, no, because you don't have to do those. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 points for this. And it's going to come out to be the same here because there's no numbers here to multiply by, so we'll get 16 points for both of these, okay?
Yeah.
All right, all these are important. I've found over the years teaching this stuff that students who are careful about the details tend to get the right answer every time, okay? Students who get sloppy or take shortcuts that aren't authorized, they don't get it right on the test, okay? And if you don't show your work, I'm not going to give you the points for it. Okay? So I could have a question like this on the test that's worth 25 points. And if all you show is the final answer, you get 3. You got to show all your work. Okay? Yeah. 1, 2, 3. That's assuming you show units and species. Okay? So you got to give me all the work. All right? Unsupported work just doesn't exist. All right, so let's add up all the points here. 98, you've already figured it out? Alrighty.